Hello, my name is Coleman Spear, and today I'll be offering you the outline to my outreach video, which focuses on the physiological effects of consuming marijuana. This is my student ID card. Hopefully that's good. With the recent legalization in Arizona and many other states, as well as near nationwide decriminalization, marijuana, or weed, has become increasingly popular as people of any age's recreational drug of choice. Much of the marketing behind weed is that it's not only safer than alcohol and other substances, but it also can be healthy for you. Another common thought is that marijuana is non-addictive. Those points, as well as the underlying physiological mechanisms that underlie marijuana consumption, will be discussed in this video. Firstly, I'd like to highlight the areas of the brain that marijuana targets. THC, or delta-9 tetrahydrocannabinol, is the primary molecule inside of marijuana that targets specific cannabinoid receptors in our bodies. Additionally, weed often contains cannabidiol, or CBD, which has less intense effects and is often used topically to aid in pain or joint soreness. There are other cannabinoids that can be found in weed and other plants, but they do not have a large enough effect to influence this video or this research. To date, two different receptors have been discovered, cannabinoid receptor 1 and 2, which are referred to as CB1 and CB2 respectively. CB1 receptors are present across the entirety of the central nervous system, but were most dense near the presynaptic clefts of the peripheral nervous system. CB1 receptors inhibit storage of cyclic AMP and cyclic AMP-dependent kinase. That's where I give my own theory, which I did not find in any of the studies. My thought is that some of the sluggish effects subjects feel after smoking could be due to the lack of cyclic AMP, causing glucose to move slower throughout their bodies. This is due to the role of cyclic AMP in transporting glucose from cell to cell, and while it's not mentioned in the study, it would make sense to me as that would slow down ATP production and may also affect other specific ion channels, which would cause us to feel more sluggish. When they were first discovered, CB2 receptors were thought to be only present inside the immune system and were not that dense, but recent studies have been shown that they are present across the entire nervous system. From what I could find, there's not as mature of an understanding of CB2's physiological mechanism, but it certainly plays a large role in the endocannabinoid system and its relation to the brain. Outside the underlying mechanism to the cannabinoid receptors, the main measurable physiological effect marijuana has on its subjects is in blood THC levels. This can be understood similarly to one's blood alcohol content, but it should be noted that there is not a simple breathalyzer test for blood THC levels, and they're instead obtained through urine samples and blood tests. Despite that, for simplicity, blood THC levels give an estimate to how, quote, stoned someone is. For the purpose of this research, I focused on the effects of the three most common ways to ingest marijuana and how that affected plasma THC levels. Firstly, joints, which is marijuana rolled in cigarette paper, blunts, which is weed rolled in tobacco leaves or cigar wraps, and edible marijuana. Before I offer the average levels, I should note that in Cooper's study, it claimed that joints produced higher plasma THC levels than blunts, but then no plasma THC differences were shown. I looked through the charts and the different graphs, and they just did not represent how joints actually offered a higher level of plasma THC in the blunts. In joints, and strangely, the only number I could find for plasma THC levels was heaped together as the mean of both joints and blunts. Despite that, the double-blind test of subjective feelings of highs from joints or blunts both had the same results, which suggests that there may be something else, such as the nicotine in tobacco leaves, contributing to the similar high effects when compared to lower plasma THC levels. Now to the numbers. After consumption, joints and blunts had a mean plasma THC level of 13.9 nanograms per milliliter with a variation of 0.4, while edibles varied from 108 to 325 nanograms per milliliter. These numbers were collected from two different studies, both Copper and Cohn, with the study of edibles using mean THC-COOH levels rather than mean THC levels. I'm not sure what the addition of a carboxylic acid functional group would do to stretch the blood levels to that large of a difference, especially considering both studies clearly outlined the effects of weed and where they were obtaining this data from in precise manners. However, there are some hypotheses, and because of the legitimate way in which the data was collected, these numbers will be considered legitimate. This insinuates that edibles offer a high level of potency, which, when compared to joints or blunts, this is consistent with anecdotal evidence, which suggests that they last longer in one's system, as well as a hypothesis from the study. This is that when orally ingested and then metabolically processed, THC is converted into 11-HO-THC, which is a similar compound which has an even more pronounced pharmacological effect when compared to activated THC. It also should be noted that in a separate study on Hustis's study, found that after a joint, plasma THC levels peaked at 159 nanograms per milliliter, suggesting that edibles may remain at their peak for longer than joints or blunts. Cooper's study took blood levels about an hour after they consumed them, as well as 30 minutes after, but this peak may come 10 minutes after the subjects ingest marijuana, so that's why it's not included. For the last portion of this video, I'd like to briefly touch on the topic of tolerance and dependency on weed. According to Hawley's study on withdrawal from marijuana, cravings and withdrawals peaked in the first 5 days after quitting, with cues such as the smell of weed or images of weed peaking these withdrawals. The largest symptom of weed withdrawal are those cravings, with the majority of patients reporting that they thought about it frequently. However, in the studies I looked through, none reported serious withdrawal symptoms that would suggest the body had become completely reliant on THC. This is likely where the thought that weed is not addictive came from, but it should be understood that despite the lack of evidence for chemical addiction, it is quite easily to fall into a mental or habitual addiction. This is a little bit longer than 6 minutes, but I just wanted to note that I had a lot to talk about, and I also didn't think that it would help to include any of the slides or graphs. I looked through the outline pretty thoroughly, and it said that while you could present data, it was also fine if you didn't have a slideshow. And that's why I simply chose to speak to the camera here and offer a maybe less fleshed out version of my outreach idea, but this definitely contains my main points and shows where I want to go with it, which I hope is okay. Please let me know if this video is fine and if my citations are properly cited. I fixed 2 of them, which I was docked a point for, so thank you.